Okay, welcome. So it's Monday, September 26th, and I would like to try to work some conversion problems for you just to kind of help you get a little more confidence. And I'd like to recommend that the way you use the video is the following. I'm going to be doing some problems that you may have worked already in class or at home, and you may have gotten through it and gotten the right answer. But what I'd like to challenge you to do is, as we go through the video, when I show the problem, like this one here, number one, um, have a piece of paper out, have your calculator, your metric staircase at the ready, and try to do the problem. Push pause, try to do it yourself, and then hit play, roll the video, and just kind of check yourself. And if you get stuck, then I'll try to help you get through it. So hopefully by doing lots of these, you'll get really confident. Okay, so here we go, 175,000 square nanometers, and we got to figure out, okay, how many square decimeters would that be? So these are areas, right? Units of area. And the first thing that you might want to do is go down to the metric staircase, and you can see that we have nanometers down here. And then the decimeter, this came up in class a few times today. Students were saying, hey, where's the, first of all, what does the prefix, D mean, like in decimeter, and where is it on the metric staircase? Well, D, lowercase d, is the abbreviation for the prefix deci, and deci means basically 1/10 of something. So a decimeter, so it'd be a deci would be right there on that step, one step below the base. A decimeter would be 1/10 of a meter, and so it takes 10 of them to fill 1 meter. Okay, so we are starting here, and we have to work our way up to the deci. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 steps. Okay, so that's 8, and don't lose sight of what that means. I know we're taking steps and we have a nice staircase here, but I don't want to get too cartoonish about it. What that means is there is a difference of 8 powers of 10 that separate these two units. Okay, so that's 10 times 10 times 10, blah blah blah, until you have 8 of them, or 10 to the 8th power. Okay, so that's what that really means. So let's go back over to our problem. So we've established that 1 decimeter equals 10 to the 8th. My pen's doesn't want to make a circle. 10 to the 8th nanometers. Okay. Now, notice in the problem we're going from nanometers to decimeters, and so you might be tempted, or you might be thinking, okay, wait a minute, how come I don't start with nanometers and go this way? Why can't I do that? And the answer is you could if you put a minus sign here, then it would be okay. But that's if you're tempted to write this, you probably realize, if you think about it for a minute, that that doesn't make much sense, right? Because a decimeter is much bigger than a nanometer, and so it's going to take more nanometers to fill a decimeter than the other way around. Okay, so again, just to reinforce the order, when you're writing equivalent statements, the order is, this one is the first unit is highest on the staircase if you're using the metric staircase. Wow, I don't know why my pen's being so finicky. And the one on the right is lowest on the staircase. Okay, you get the picture. Okay, so going back over here, deci is definitely higher than the nano. So we're going to start by writing our equivalent statement with the deci. Okay, let me clean this up a little bit here. Okay, get my pen back. All right, so now, are we done? Do we have our equivalent statement all ready to go? Well, not quite, not quite, because you'll notice that these are not just straight units of decimeter and nanometer. We've got squared and squared. So we need to do the same thing down here, okay? So when we square, we have to square both sides. Okay, now I'm going a little bit slow on this one. I realize some of you, those of you who are, kind of a little more comfortable with it, you can skip ahead, but for those that kind of want a little bit more, reinforcement, a little more assurance, I'm going to go a little bit more stepwise through this first one. So bear with me. All right, so, and when we square, then 1 squared is still 1. Decimeter squared is decimeter squared equals 10 to the 8th squared is 10 to the 8 times 2, or 10 to the 16th, and then nanometer squared is that. Okay, so now we have our working equivalent statement. So now let's apply it to the problem. Okay, so then we're going to, again, we start by writing what we know. Okay, so we have 175,000 nanometers squared, and that's a multiply, and we're going to do a conversion. Okay, so we want decimeters squared in the answer, and so what that means is we need to put the decimeters on top. And don't forget what we want as far as units goes on top, and what we're trying to cancel out goes on the bottom. Alright, so your setup should look something like that. And let me multiply this out here in real time. 175,000 divided by 10 to the 16th is 1.75. So the answer is 1.75 times, oops, didn't leave myself enough room here, times 10 to the minus 11th power. Okay, and that's decimeter squared. Okay, and on your, whenever you're doing this for real, especially like on a quiz or a test, make sure that your final answer is, you've got to put a box around it, and then don't forget the all-important units. Okay, because I'll count off if you don't have your units. This is a property of length, or of area, and so you have to label it as such. Otherwise, people don't really know whether you're talking about length or mass or what have you. By the way, I didn't show explicitly canceling out units, and you can see that we ended up with decimeters. Okay, so that's the process. That's how we do that. Let's try another one. Let's go down. I think I picked another one out here. Yeah, let's try number 4. First of all, let me see if we can get rid of some of these objects. Sorry about the graffiti. My writing tablet is being a little bit flaky today. I don't know what's going on. Okay, sorry about that. Okay, so here we go with trying to make this so it's not. Okay, hang on 1 second. Okay, alright, I'm back. Under control. Okay, so this problem, 1250 milliliters, and we've got to convert that to cubic millimeters. Alright, okay, so I think we talked about in class, we introduced this the equivalences between these various units. So you've probably heard on TV, or maybe in medical context, a cc, a unit of volume, can be expressed in terms of cc's, and cc is nothing more than the abbreviation for cubic centimeter. Okay, so that's all that is. Okay, cc, and that's equal, so a cubic centimeter is 1 cm to the third power, which is equal to 1 milliliter. Okay, and I think I went over this in honors, but just so if I have, we can make a little cube here, 1 centimeter on a side, okay? And if you have 1 centimeter on a side with a cube, then that would contain exactly 1 milliliter of a fluid. Now, if you take a bigger cube, and let's say we make it, say 10 centimeters long, and we make that into a cube, 10 centimeters on a side, then that would be, the number of cubic centimeters would be 10 times 10 times 10, right? And so that would be 1,000 cubic centimeters. And it turns out that because, now follow me on this, because 1 centimeter is equal to 1 milliliter, if we have 1,000 cubic centimeters, we have 1,000 milliliters, right? So this equals 1,000 milliliters. And you guys probably know another way of expressing 1,000 milliliters, right? That's 1 liter. Okay, so if you have a cube that is 10 centimeters on a side, you could contain exactly 1 liter of fluid in there. Okay, all right. So now let's get back to business. When you stand back and think about, okay, oh my gosh, how am I going to get from milliliters to cubic millimeters? I think first, if you kind of work backwards on this, you would say, well, okay, I know I could get from centimeters cubed to cubic millimeters. That, you should kind of have a sense that, yeah, we can do that. That's just a metric conversion. And because of this relationship here, milliliters to cubic centimeters, we know we can get from there to there. So I think you can see that we can see our way from milliliters to cubic centimeters. All right, so let's back up. Let me clear some. Let's see if I can clear this out. All right. Okay, so first equivalence we need is 1 milliliter equals 1 cubic centimeter. Okay, so that's the first equivalence. The second equivalence we need is getting from a centimeter cubed to a millimeter cubed. And because these are both in the metric system, it's going to be a power of 10. We just have to figure out how much. What is that power? So over here, we can start. You can always start from scratch and say, okay, let's just take non-cubed centimeters and figure out how many millimeters we'd need, right? Well, you guys probably know this, just from experience, that it takes 10 millimeters to fill a centimeter, right? So, here you have centimeter, here you have millimeter. They're separated just by 1 step, so that's 1 factor of 10, okay? So, it's the first power, 1 centimeter equals 10 millimeters. Then if we cube both sides, okay, then we have 1 centimeter cubed equals 10 to the third millimeters cubed. All right, and so so we need the power of 3 here, and boom, we've got it. We've got both of our equivalence statements. All right, so let's take what we've got. Now we're ready to apply conversion factors. So we're going to do the conversion. So we start with the thing that we're going to convert, 1250 milliliters, and we're going to apply basically 2 conversion factors, and if we do it right, we'll get some number in terms of millimeters cubed. All right, so first step, we want to get rid of the milliliters and go to centimeter cubed. So we do that, okay, and milliliters cancel out. That's good. Then we apply the second conversion factor, which uses the second equivalence. We want to go to cubic millimeters, so that's 10 to the third millimeter cubed. I got that from right here. And so the other side goes below. Okay, and by putting the centimeters cubed in the bottom, that lets us cancel centimeters cubed. And so now we're left with, when you multiply 1250 times 10 to the third, you get, in scientific notation, 1.25 times 10 to the sixth, and that's millimeters cubed. Okay, so there we go. That's how you approach that problem. All right, and again, before I move to the next problem, I just want to reinforce, because I know this has given a number of people problems. In order to multiply the given number by a number like 10 to the third, don't forget that 10 to the third in scientific notation is 1 times 10 to the third. Okay, you don't change these two numbers expressed in these 2 different ways are absolutely equivalent. And you know, if you multiplying anything by 1 just leaves the thing unchanged. But to express a number in scientific notation, you have to have a coefficient, which is the 1 here, and then 10 to an exponent. All right, and so in your calculator, especially if you have EE buttons, you're going to type 1 and then EE3, and that will be interpreted by your calculator as, you know, 1 times 10 to the third. Okay, just checking my time. All right, so I'm going to pause here. I need to upload the video before it gets too long, and I'll continue with the second part.